Okay, today we're going to look at some applications of polynomials and rational functions. And we need one or two definitions. And then the easiest way to actually do these problems is to actually do them and work through them and understand what they're asking. So what we're going to look at is what's called variation problems. Essentially, the idea is in the real world, quite often one quantity varies with respect to another. When you're driving your car, the faster you drive, the less time it takes to get where you're going. As one thing varies, as your speed varies, something else varies, the time it takes to get somewhere. And that occurs repeatedly throughout math. When you think about area, as the length of an object gets bigger, if the width is fixed, then the area will get bigger. So we want to kind of throw all these variation problems together and solve them all out. And the good thing is, with one or two definitions, we can solve every single problem, and they're all solved the exact same way, which is pretty straightforward. So first, we're going to look at direct variation. And as far as the definition goes, we'll just say y varies directly with x if y equals kx. And the idea is when you're reading a problem, and we'll look at a lot of applications, and you'll see a lot in your book and do a lot in your book for homework. When you're reading the problem, as soon as you see y varies directly, as soon as you see y varies, you immediately get an equation. And when you have varies directly, your equation is y equals kx. X and y are your two variables. K is actually a constant, and it's called the constant of proportionality. And as far as it goes, well, as soon as you see that something varies, you get an equation, you plug in numbers, and you solve, and you're done. We'll see that in a second. One thing I would point out, though, this is called the constant of proportionality, because another way of saying this is that y and x are proportional. So just be aware in your book, when you're reading problems, most of the time your book will say y varies directly with x. Sometimes it might say y is proportional to x. They mean the same thing. They mean y equals kx. The easiest way to understand these is to actually solve some problems. So, suppose we say, let's see, the monthly payment on a loan varies directly with the amount borrowed. If the monthly payment is $50 on a $1,000 loan, find an equation relating these quantities. Okay. The monthly payment on a loan varies directly with the amount borrowed. If the monthly payment is $50 on a $1,000 loan, find an equation relating these quantities. One other thing I'll point out, when we look at variation problems, we look at a lot of applications in a lot of different fields, physics, engineering, astronomy. Don't get lost in the words and the really confusing stuff that you may have never heard of before. All that really matters is varies. In this case, varies directly. As soon as you see that, you're done. You know what your equation has to be. And as far as writing it goes, you can use the standard y equals kx. A lot of times when solving these things out, just to keep them straight in our heads, we'll pick variables that make sense in the context of the problem. So in this case, maybe the monthly payment, call that M for monthly payment. Monthly payment varies directly, so M equals K times the amount borrowed, so call that B. Now we have an equation. When you're solving them, you can use either one. I'll generally, when doing these, pick variables based on the problem, just to make it make more sense. But the way it works mathematically is, we have an equation relating these quantities, but we're not done. You can only use this equation if you find the value for K. In order to find the value for K, algebraically, you need an M and a B that are related. And the good thing is, in every single one of the problems you solve, you can't solve it unless they give you the M and the B, so it has to be in the problem so you can just find it. In this case, if the monthly payment is $50 on a $1,000 loan, so let's see, M is equal to 50 when B is equal to 1,000. So now just plug it in and solve. 50 equals K times 1,000. Then just divide by 1,000 on both sides, and you get 0.05 equals K. Now, rewrite your equation, and you get M equals 0.05B. Now you have a nice equation, you solve for your K, and you're done. That's pretty much all we're doing. A lot of times you can actually add a second step to this, and you could maybe say something like, what is the monthly payment if you borrow $20,000? But to do that, if you want to find the monthly payment when you borrow $20,000, just plug in $20,000. And then solve that out. And in this case, I think if you actually solve it out, you'll get $1,000. And there you go. As far as it goes, that's it. Once you talk about variation, once you know in your problem that it says it varies, you immediately get an equation. Use y equals kx or pick some other letters, it's entirely up to you. But you immediately get an equation, and then the first step is always solve for k. In order to solve for k, you have to be given enough information to plug in for the other variables. There we go. Plug in for them, get your k, and rewrite your equation. In theory, there can be a kind of a second half to the problem, where they give you more numbers and you plug in and solve for some other variable. So as far as it goes, these are really straightforward. The topics they talk about, borrowing and monthly payments, we'll talk about engineering and physics and astronomy and other fun stuff like that. The topics are irrelevant. As soon as it varies, your equation is set in stone and you can just kind of plug in numbers and solve from there. So, we're going to look at a few more examples and a few different types of variation, and then we'll be good. The next thing we want to talk about is what's called inverse variation. As far as the definition goes, y varies inversely with x if y equals k divided by x. Essentially, direct variation means multiplication, inverse variation means division. But other than that, everything is the exact same. For a given problem, if you have inverse variation, write your equation, y equals k over x. You have to be given values of y and x in order to solve for your constant k. And then once you solve for k, plug it in, and then maybe given an x, find y, or given y, find x. But essentially, the method of solution is the exact same. We're going to look at one or two examples probably on another video, so this one doesn't become too long. But just so we know, there's one more type of variation. There's what's called joint variation, which is also called combined variation, but your book uses joint. And for a definition, y varies jointly with x and z if y equals kxz. Essentially, the idea, in the real world, we talked about monthly payments and loans and the speed of your car and the time it takes to get somewhere. Those problems are simple. They only have two variables, two things that are related. In the real world, generally speaking, lots of quantities, lots of variables are related. So you can have things like joint variation. Essentially, anytime something varies directly or jointly, you multiply. Anytime something varies inversely, you divide. One little note I'll make, each of these equations has a k in it. When we start solving more complex ones and look at some more complex examples, it doesn't matter how many different types of variation you have, you always only have one k. There's one constant k. And then you say, what's varying directly or jointly, multiply by it. What's varying inversely, divide by it. Like I said, I'm going to finish this video with just the definitions. The next video will actually run through a couple of examples and we can kind of work them out.